Okay, welcome back everybody. So we're continuing with our review here. We're going to talk about finding the equation of a tangent line given a curve and power rule derivatives. So the power rule derivatives are going to get a little messy because I know you guys don't like it when they're fractional exponents, but we'll get to it. So first, the main definition of a tangent line is a tangent line will tell you the instantaneous rate of change of a curve at a point. And it can be found by evaluating the derivative of the curve at that point to find the slope, and then use the slope and the point to find the equation of the line. So let's look at an example here. I'm just going to make this up off the top of my head, so that means the numbers are going to be super nasty. Let's say we have some curve that is y equals, I don't know, let's do x cubed minus 4x squared plus x minus 8. And I want to evaluate this at the point 0, negative 8. So I want to find out what the, oh no, that's going to be too easy. That's going to be way too easy. Let's not do that. Let's evaluate it at the point, let's do negative 1, comma. So if I put a negative 1 in here, what do I get back out? So this is negative 1 minus 4, so it's negative 5, negative 6, so negative 14. So I want to evaluate this at that point, find the equation of the line tangent. Step number 1, you find the derivative of the original function. So that is y prime is equal to 3x squared minus 8x plus 1. Step 2 is to evaluate the derivative at that x value. So you only want to use the x value for this part. You don't want to plug in the y value, just the x value. So y prime of negative 1 is going to be equal to 3 times negative 1 squared minus 8 times negative 1 plus 1. So negative 1 squared is 1 times 3 is 3. Negative 8 times negative 1 is plus 8 plus 1. So that means the slope of the line tangent at that point is going to be equal to 12. Now that I know what the slope is, and I know the point, I can find the point-slope equation and use that to find the slope-intercept equation. Now, I know not everybody likes the point-slope equation, but I'm going to just make one final case for it. This is the last time you'll have to hear me argue for using point-slope over slope-intercept. So the point-slope equation is y minus y1 equal to the slope times x minus x1. In this case, plane y stays plane y, plane x stays plane x. So substituting in my values, it's going to be y plus 14, because minus negative 14 is positive 14, is equal to 12 times x plus 1, because minus negative 1 is plus 1. Now from here, if I distribute to both things inside, the right-hand side turns into 12x plus 12. And if I subtract 14 from both sides, that leaves me just y on the left. And now I've got y is equal to 12x minus 2. I think this is significantly easier than if you go all the way back and do y equals mx plus b and substitute in negative 14, 12 times negative 1 plus b, dot, dot, dot. I just think this is so much easier. But again, like I said, this is the last time I'm going to be making a case for it. All right. The other thing we're going to be talking about for today's review, or this week's review, is using the power rule to find derivatives. And in general, the power rule is totally fine. I already used it up here. If you have a variable to a power, the power comes down and the variable drops 1. And then if you have something that has no x, then that goes away. Where it starts to get an issue for you guys is in two cases. One, when you have a fractional exponent. So let's say we have a function y is equal to 4th root of x to the, let's say, 3rd. And you want to find the variable of this. This is really just a power problem. The other place it causes an issue is if you want to find the derivative of, say, y is equal to 3 over x squared. Now, these are two different problems, but they both use the power rule. So for the one on the left here, you need to turn this into a rational exponent, meaning there's a fraction in it. So I'm just rewriting the function now. I'm not doing anything with the derivative yet. So rewriting the function, whatever number is in here is going to be the numerator of that power. So numerator. And whatever functions or whatever numbers out here is going to be the denominator of the power. denominator. So if I rewrite this isn't the derivative yet, I'm just rewriting it. This is going to be x to the 3/4 power. Now from here, I can just use the power rule as normal. But again, because it has to do with fractions, it's going to freak you guys out. So using the power rule, y prime is going to be equal to, I'm going to take this power, drop it in front, and multiply it by whatever was there. In this case, just 1. So 3/4 x. And then the new power of x is going to be whatever the old power was minus 1. 3/4 minus 1 just happens to be negative, be negative 1/4. Now, I'm pretty sure delta math isn't going to be okay with this. You guys can try. I don't think it's going to be okay with it though. So the actual answer then would be y prime is equal to 3/4, and then x to the negative 1/4 power means we're going to have 4th root, because that's what the denominator is. And then inside we've got x to the numerator's power, which is 1. And the negative part means this is all over, or all underneath a fraction. Now again, I think delta math won't accept this, but we'll test it in just a second. You need to further multiply these two together. So further multiplying these two together, you would get 3/4 times the 4th root of x to the 1st. So this would be an okay answer, even though it has a radical in the denominator, which is technically considered inappropriate for math. But pretty sure this is what delta math is looking for. We'll test that in just a second. All right, now looking at this other example over here. So if a variable is in the denominator, that means that variable actually has a negative version of its exponent, and it can come out of the denominator then. So again, I'm just rewriting this. I'm not doing any math yet. So this is going to be the same as y is equal to 3 times x to the negative 2nd. So if I change the exponent negative, it gets to come on top with the other stuff. Now from here, the power rule still applies. So negative 2 is going to come down and multiply by whatever the coefficient was, which means this is going to become negative 6x. And then this is going to drop by 1, which is going to make it x to the negative 3rd. Now again, I'm pretty sure delta math is going to want you to have only positive exponents. So that, this should be y prime. So that means that your y prime should be negative 6 over x to the positive 3rd. This is the derivative they'd be looking for. But let's test that. So let's take a second and take a look at this week's delta math assignments. If I jump over here, let's look at equations of lines tangent. So this is the lines tangent. So again, first you find the derivative. So the derivative of x squared minus 2 is 2x. And then you're going to evaluate f prime at 8, which is 2 times 8, which means the slope is 16. And we're looking for the full equation of the line tangent. It doesn't give you a y value, but you can find that y value pretty easily. So if I take 8 and plug it back in here, 8 squared is 64, 64 minus 2 is 62. So now I know my slope is 16, my x value is 8, and my y value is 62. So y minus 62 is equal to 16 times x minus 8. If I distribute the 16 to both things inside, this is 16x minus 128. And if I add 62 to that, to get rid of it from the other side, that means y is equal to 16x. Let's see, negative 128 plus 62 is negative 66. Let's see if I'm right. It'd be funny if I were wrong. I don't think I am, but it'd be funny if I were. So y equals 16x minus 66. Here we go. Cool. Now, there is another case that these show up that I forgot to go over in our notes, but let's take a look at that right now. Okay, sorry for that weird cut. I decided to just axe that other section of the equations of tangent lines. So we're going to take a look here at our skills. So I'm not going to go through one of each of these. This one should be really easy. The derivative would just be 9x squared plus c, or yeah, no, 9x squared. Sorry. And then derivatives of polynomials. Yoda. So this one shouldn't be too bad. This should be 40x to the fourth minus 36x to the third plus 6x squared. We go back here. We're finding the derivative and evaluating it at 2. So the derivative would be 4x minus 2. And then if we plug in a 2, 4 times 2 would be 8. 8 minus 2 would be 6. The last one, and these are the ones that I think might cause you guys some trouble, would be something like this. So let's talk about, without using negative exponents, simplifying all fractions. Let's talk about how this should look. So starting with rewriting the function. So I have my function f of x. To rewrite this, if there's no number inside a square root, the number that's there is a 2. So this is going to be x to the 3/2 power over 4. I know, girl. I know. She likes listening to me talk. All right. So x to the 3/2 power over 4. This is also the same as 1/4 times x to the 3/2 power. Now, from here to find the derivative, again, it's just the power rule. We're going to take what's on top and multiply it by whatever coefficient was there. So 3/2 times 1/4 becomes 3/8. And then x is now going to be raised to 1 less than what it was. 3/2 minus 1 is 1/2. This is f prime of x, which means that the actual derivative needs to be rewritten so that we're not using in radical form. Yeah, it needs to be in radical form. Let me actually test to see if it's going to be okay with me writing it as the exponent one. So if I want to write this as 3/8 and then times x to the 1/2, I wonder if it'll accept that. Nope, it didn't. So it needs to be 3 radical x over 8. So it's simplified or is not in the correct form. Cool. So you guys need to make sure that you're rewriting it in the form that you were given it. And this actually answers that question for me. So let's look at another one of these. So here we've got f of x is equal to 2 over the square root of x to the 5th. This is the same as saying it's 2 over x to the 5 over 2, x to the 5/2. But since it's in the denominator, it's also the same as saying this is f of x is equal to 2 times x to the negative 5/2 power. The negative 5/2 will multiply by what's in front. So negative 5/2 times 2 is negative 5. And then dropping 5/2 by 1 power would be to the negative 7/2 power. And then rewriting this so that it's on the, or in the denominator, would be negative 5 over the square root of x to the 7th. And yeah, there we go. So that's what it should be. So to write that in here, I'm going to do negative 5 divided by the square root of x to the 7th. All right. And there we go. Cool. So let me know if you guys need any help. This one's a little bit more difficult than what we've been doing, but hopefully it's still not too bad. If you need help, let me know. We can do email, we can do Google Hangouts, I can set up a Zoom meeting, whatever I need to do to give you guys help, I'm totally willing to do. So I hope everybody's doing well, not going crazy, and yeah, flatten the curve. Hopefully I'll see you guys soon.